We got 13.2. And where am I going to start? I'm half tempted to do this for you, but I'm not going to. So draw the given angles. Let's do the first one. That way everybody gets at least the first one. This is a negative angle. A negative angle rotates like a clock. All right, it rotates negative 240 degrees. Now everybody should know that a semicircle is 180 degrees. Doesn't mean you do, but you should. So if I start here and rotate here, what I've actually technically done is I've added in 180, and I would have negative 60 degrees of rotation left. That'll get me about right there. So the angle starts here, terminates here, but this is the actual rotation. Now a negative 240 degree angle is equivalent to a 120 degree positive angle. There's that aspect. 9 pi over 4, what you're going to have to do is you're going to have to do your conversion. You're going to have to take your 9 pi over 4, and you have to multiply it by 180 over pi. And you know, for some of y'all, you're going to have to be button pushers. Just nothing we can do about that. So you take your 9 pi over 4 and you multiply it by pi over 180, or sorry, 180 over pi, because you want the pi's to cancel. And there we go, 405 degrees. Now what I would have done is I would have done this and this, and then I would have said, okay, 4 goes into 180 45 times. 9 times 40 is 360, 9 times 5 is 45, 360 and 45, 405. But that's me. And this is a positive angle, which means it rotates counterclockwise. So we're going to start on the positive x-axis, just like we always do. Start here. We're going to rotate a complete circle, and a complete circle is 360, which gives us 45 degrees of positive rotation to go. There you go. It's not a hard skill. Anyways, there's two of them. Should keep this docked. Alright, what's next? Convert the following measure into degrees or the radian measure degrees. Show your work, and that helps you memorize your formulas. They all work out pretty good. They do, except for like 13 and 15. They all work out pretty good. So negative pi over 4, what I would want is I would want the pi symbols to cancel out, so I'd put a pi in the denominator. The pi's would cancel. And I'd have, that's a multiplier symbol by the way, I'd have negative 180 over 4, which is negative 45 degrees. You're more than welcome. There's other ways of doing this. You're told in your notes that pi is worth 180 degrees. Like, you're told pi is 180 degrees. That's what she is. So anytime you see a pi symbol, you could just replace it with 180. Ta-da, negative 45. So that's something you can do. Like on number 11, if I use that technique, I would say, aha, that's 180. 5 times 180, sitting pretty over at 12. Let's see what that is. 5 times 180 divided by 12, 75 degrees. Alright, let's do 14. We got a negative 260 degree angle, and we're going to multiply that by pi over 180 degrees because it's the degree symbols that we want to cancel. That's why we do that. I'm going to go old school on this. The zeros cancel, the degree symbols cancel. I'm at negative 26 pi over 18. I'm still an even number, and even numbers are always divisible by 2, so negative 13 pi over 9. Now, if I'm doing this in a calculator, what I do is I do negative 260 times 1 over 180. If I don't have number sense and I'm a button pusher, I do everything without the pi key. Math, enter, enter. And there she is, negative 13 ninths don't forget about pi. How could you dare forget about pi? 13 is a radian. It's the same formula. You take 1.7, it's the same thing, but pi is built into this number. This is like a little more than half of pi is what it is. Anyways, you take 1.7 and you multiply it by 180 over pi. That's all you do. And this is just going to be a bad-looking decimal. That's all it's going to be, is a bad-looking decimal. So you got 1.7 times 180 divided by a pi. It's about 97.403 degrees. And I know what radians do to kids. This one is in your notes. If you took them. Because some of y'all don't really try too hard. Alright, what do we have to do here? Draw the sector described, then find its arc length and area. If possible, give your answer in exact form, and every single one of these can be done exact form. It's not if possible, it can be done. Now, your formulas are S, which is arc length, is equal to r theta, and area, which is A equals 1/2 r squared theta, have kind of a kicker. Theta must be a radian. Okay, so I'm going to do 18. Like this one's fine, that's a radian. These have to be changed. So I'm just going to do 18. Actually, I'll do 19. You know, in my head, I do 150 times 180 over pi. Sorry, pi over 180. And I'd have 15 over 18, both divisible by 3, and I'd end up with 5 pi over 6. And I know some of you are like, what is this magic he's doing? I can't even add two numbers together. How is he doing this? So for you, 150 times 1 over 180 math, whoops, not alpha, math, answer frac. 5/6, don't forget about pi. I wasn't doing magic. You just kind of stink at math. Alright, where are we at here now? Alright, we're supposed to find, and we're supposed to draw this thing too. So draw the sector. We have a 150 degree angle, which looks about like that. It's probably a little bit wider. It's probably something like this. And a sector is a giant slice of pizza. The central angle is 5 pi over 6. And the radius is 25. That's what it looks like. Alright. Now the arc length, and arc length again is going to be what I'm highlighting here. That's my arc length. It's simply found by doing the radius times theta. So it's going to be S equals a radius of 25 times 5 pi over 6. 25 times 5 is 125. Don't forget about pi over 6. I don't believe that'll simplify, but it's pretty early in the morning. So let's do everything without the pi symbol, just so we can check me. 125 over 6, don't forget about pi, and this would be inches because it's length. Your area is going to be 1/2 the radius squared times the central angle 5 pi over 6. So if I take a 25 and I square it, I should get 625. Then I've got a 5 there. I should get 3,125. The bottom is going to be 2 times 6, which is 12. Don't forget about pi. 3125 over 12. That might simplify. I don't know. 3125 sitting pretty over 12. I don't think it will, but it might be divisible by 3 and I'm just too tired. Yeah, it didn't. Now, again, if you can't do any of this, we have a half. We have a 25 that is squared. then we have this 5 over 6. Notice what I'm doing? There's no reason that this can't be done by some of y'all. You just don't want to do it. There you go. Don't forget about pi. Now this is area, inches squared. And moving forward. Last one I'm going to do. A spiral staircase has 15 steps. Each step is a sector. Each step is a sector. And this is what a sector looks like. With a radius of 42 inches and a central angle of pi over 8. And I'm really happy that that is a radian. I'm really happy that's radian. Anyways, this is what it looks like. You're supposed to draw it. You should be drawing it. And what is the length of the arc formed by the outer edge of the step? So the length here is simply going to be r theta. The radius is 42. The angle is pi over 8. And if we do some reduction here, we'd have 21 over 4. So 21 pi over 4 inches. Now, this is a real-world problem. I would not answer a real-world problem in exact form. It's about 16.49 inches. Through what angle would you rotate by climbing the stairs? Include a 16th turn. So each turn rotates pi over 8. There are 16 turns. So you can see include a 16th turn. So the total rotation is equal to 16 of these pi over 8s, which is 16 pi over 8, which is 2 pi. And 2 pi is 360 degrees. Straight from your notes, we talked about it. Or at least we will have talked about it. I'm doing this before I actually teach y'all. Alright, see how many square inches of carpet would you need to cover the 15 steps? So I need area. The area of a step is going to be 1/2 r squared theta. The radius is 42 inches. The angle was, and that's got to be squared, and the angle was pi over 8, I think. Let's just do this in exact form. We've got a 1/2. We've got a 42 that's squared. Then we got a pi over an 8. Oh, I put pi over. Idiot. Till I'm tired. There we go. So if I like exact form, I'm 441 over 4 pi square inches. If I don't like exact form, I put the pi back in it. I'm 346.36 square inches. 346.36. That's each step. So when you talk about all 15, I'm going to just say 15 times this guy right here. I'm using all the exact numbers in calculator. So I need 5,195.41 square inches. 5195.41. That's what I need. Now, how many square foot? A foot is a 12 by 12, which is 144 square inches. So what I'm going to do square feet is I'm going to take 5195.41 and divide it by 144. Now I'm going to get 36.08 square feet. And I also asked about yards. I didn't do that on the original paper. It's just something I wish I had, because kids need to know how to convert between units here. Talk about square yards. All right, a yard, you should know, is 3 feet by 3 feet. Or sorry, a yard is 3 feet. A square yard is 3 by 3, which is 9 square feet. So I'm going to take this result, 36.08 square feet, and divide it by the square footage in a yard. There's 9 square feet per yard. And I'm going to get something a little more than 4. Sorry. About 4.009 square yards. Now what you're going to have to do is you're going to probably have to buy 5 square yards. That's what you're going to have to do. And you're going to need it too, because you're going to make mistakes and you're cutting out circular things. There's going to be so much scrap on this job. That's probably why they don't do them too much anymore. But there you go, your spiral staircase problem. So that was the homework for Monday.